we can look at the points that they gave us there. So if you can substitute the value directly into the expression, right? Or simplify the expression until you can substitute the value in, drop the limit notation only once you sub in. Looking at this first one, we can immediately substitute x to be 2, right? So we know it will simply be equals to 2. That is the limit of x as x approaches 2. That's just what it is. We can substitute in. Okay. Now for this one, for the next question, so I'll say question 1, then question 2. For question 2, we cannot substitute x to be 2 because we're going to have 2 minus 2 in the denominator part. So we need to simplify, right? So I'm going to say equals to the limit as x approaches 2 of what? X plus 2, x minus 2, and x minus 2 in the denominator part. So what happens? This can cancel that. Okay, now that we have something that looks like that, so what we have, let's see, x to the 2, x approaches 2, x plus 2. We can then substitute the 2 in so that we have 4 as our limit. Okay, I'm quickly going to jump to the next one. Yeah. Okay, so as I explained in my summary that the average gradient we calculated using any 2 points. So if they give you function and they give you 2 points and they say to you one average gradient between those 2 points, you can still use the gradient formula, which is 1 over x2 minus x1. That doesn't change. Okay. Now let's look at this gradient formula that we are used to. I'm sure you guys have seen this. You must have seen this at least a number of times, and you must have used it a number of times. Okay, so let's say we have a function. Maybe let me use so I'm going to look at these 2 points, point A and point B. So what I'm going to say about the coordinates of A, I will say I have x and f of x. Those are just the coordinates of A, nothing fancy, right? Now the distance between, the horizontal distance between A and B. So let me do this. You can see exactly what I'm talking about. The horizontal distance between A and B, I'm going to call H, right? Now, if I say something, it means that the coordinates of B should be x plus h, and the y value should be f of x plus h. All right. Now, what do we do? How do we find the gradient of this? We say y2 minus y1 over x2 minus x1. So I will have f of x plus h minus f of x. This is my y2, this is my y1. Over x2, which is x plus h, minus x1, which is just x. All right. Now, we can simplify that. Notice something. This x cancels that x. So what are we left with? We're left with f of x plus h minus f of x all over h. Okay. But now in calculus, what we do is we look at points that are very, very close to each other. And when I mean close, I'm not even talking about 0,5 or 0,25 or 0,1. They must be very, very extremely close to each other. That's when we will introduce the limit. We will say limit as h approaches 0. So it's very, very small. Now, if you take the limit as h approaches 0, what you will get is the derivative formula or the first principles formula. And that's where it comes from. I'm hoping we're all clear there. Okay, there are no questions. I'm going to carry on. Okay. Now, let's quickly look at this. Find the derivative of the following function using first principles. Like I was saying, the easiest 4 to 5 marks that they can ask you in paper 1. I always just do it first. I always just use the power rule to find my derivative. I know that f prime of x must be equal to 2x plus x. Okay. Sorry, plus 1, my mistake, plus 1. There we go. Yes, 2x plus 1. Now, let's try to differentiate that. F prime of x equals to the limit as h approaches 0 of f of x plus h minus f of x all over h. And notice something, I'm not going to drop the limit until the very end. So the limit as h approaches 0 of x plus h, but originally it was squared. Plus, there's another x, which I need to add an h to it. Then I have to say minus f of x. I'm going to keep it in brackets, like I was saying, because we have two terms. X squared plus x all over h. Then this is equal to the limit as h approaches 0. Now, let's clean that up. So the top part is going to be x squared plus 2hx plus h squared, then plus x plus h minus x squared minus x all over h. Now, there must be some things that are canceling out. If you reach the step and nothing is canceling out, you need to go back and just double check if you haven't made any mistakes. Okay, so this cancels that x with this x. Okay, now I'm going to take out a common factor of h. So the limit as h approaches 0, don't drop. If you drop it, you drop a mark. So h outside, what's going to be left? 2x plus h plus 1. These two cancel each other out. Okay. Now, finally, this h approaches 0. Then it means that f prime of x equals to 2x plus 1. Because that's what we are left with. And that's what we found using the power rule. So we are on the right track. No, Colin, they are not going to ask you to derive that formula. I was just showing you where it comes from. It's just an easy thing, but you don't have to memorize it or learn it. Okay, let me just clear the screen. Okay, then differentiation using the power rule. We spoke about this in my summary. Okay, just want to give you these to look at here. Okay, so find f prime and f prime prime of these kind of questions. This is not too bad at all. Why am I saying it's not too bad? Because you need to remember what I explained, that you need to get them in the form k x in. Constant x and a. We should be able to do that. Let's try to get it in that form. Here, I'm going to write it, I want to separate it. X over x to the power 4 minus 3. I know that this is x to the power of 1 over 3 over x to the power of 4. Then there's a minus 13 at the end. It's still not in this form. I'm going to try and get it in that form. So here we have 1 over x to the power of 3 minus 3. I'm going to just say this is x to the 1 over 3 multiplied by x to the minus 4 and minus 13. Let's fix this. This is just x to the power of minus 3 with a 1 in front. Then this is just 3x. Then it's just easy work because all we do is we simply say 1 over 3 minus 4 on our calculators to find the new exponent. So that will give you minus 11 over 3. Then there's still minus 13 there. Now we have it in the form kx to the power of n. Let's differentiate. So y prime will be equal to minus 3x to the minus 4. Then this is going to be plus 11x. Then 11 over 3, negative 11 over 3 minus 1 will give you negative 14 over 3. And then we know for a constant, it falls away. And this is our derivative. Okay? Now for the second derivative, you just differentiate it again. I'm hoping that is clear. Okay? Now for this kind of a question, what would we do there? So we need to try and factorize. So x plus 1, I'll write it as in a bracket. Then here I can try to factorize. I know I'm going to have positive and negative x there, x here. So the factors of 4, if I put a 4 and a 1 there, that should work. What cancels this and that cancel? What am I left with? X minus 4, which is definitely in the form 1x to the power of 1, the kx and n. Okay, then that's just a constant, it will fall away. So it means that our derivative is just 1. Okay, now before we move on, why is the derivative of a constant equal to 0? Why does it fall away? So let's think of any constant. 7, let's take 7. So if it's 7, right, if we write it in this form, kx to the power of n, we're going to have 7 multiplied by x to the power of 0, because x to the power, anything to the power of 0 will give you 1. So x to the power of 0, 1 multiplied by 7 is just the 7 that we started with. Okay? Now let's differentiate that. We're going to have 0 multiplied by 7 multiplied by x to the 0 minus 1. But remember that this, this, well, it doesn't matter even if you don't know what it is. The fact of the matter is that we are multiplying by 0 in the beginning. 0 multiplied by anything else will give you 0. And that's why all the derivatives of constants will always give you 0. Okay? I'll bring that together there. Let me just clear my screen. Okay, now let's look at some notation. So we have the Lagrange notation, right? So the Lagrange notation is the f of x1, where we have the first derivative as f prime of x. Okay, so remember these are scientists who helped with the discovery of calculus back in the day, and each and every scientist is using their surname there, so that the notations are really okay. F prime prime is still under the Lagrange notation, and then there's Leibniz as well. And Leibniz notation is the one where we use y, right? And if we're trying to find the derivative of y, we have to say dy over x. So the derivative of the function, 6x minus 2. Okay, and then Euler's method or Euler's notation, it's the one where we use a capital D, the subscript of x, and then we differentiate that. So the working out is still the same. The answer that you mark it at the end must be the same. I'm hoping we're all together there. Okay. Let's quickly look at one more differentiation from first principles. So it is saying find the derivative of the following function using first principle. What do we know? We know that our answer at the end must be 4x because we just multiply, right? So this is the power rule. Now, what are we going to do there? F prime of x equals to the limit as h approaches 0, f of x plus h minus f of x all over h. The limit as h approaches 0. Yes.
Muboka from TikTok says, please slow down a bit.
Yeah, you can go ahead.
I'm saying
Muboka but I'll try.
From TikTok. Okay.
Okay. I'm gonna try and slow down. So yeah, the limit there. So we know we're gonna have 2 into x plus h, but this was squared minus 4. Then there's a minus in brackets, please. 2x squared minus 4. Then close your bracket all over h. And this is the limit as h approaches 0 of 2 into x squared plus 2hx plus h squared minus 4 minus 2x squared plus 4 all over h. Then we know the limit as h approaches 0 because we don't want to lose any marks. 2x squared plus 4hx plus 2h squared minus 4 minus 2x squared plus 4. Still all over h. What cancels? This and that cancel. This and that cancel. Then we can take out a common factor of h. So the limit as h approaches 0, h outside, 4x plus 2h all over h, that and that cancel. This h approaches 0, so f prime of x will be the 4x because that's what's left. I'm hoping we are all together there. I'm not seeing any questions on the Zoom chat, so I think you guys are fine with that. Okay. Now, on the issue of derivatives, I want to show you something a little bit nice that you probably didn't know. Let me just erase this. So think of this function. F of x equals to ax squared plus bx plus c. Now, we know that the x value at the turning point is negative b over 2a. But did you know that we got this from differentiating? So we said if prime of x equals 0 for the turning point, because that's a minimum or a maximum turning point, we're going to say 0 is equal to 2ax plus b. Then we're going to try and solve for. So minus 2ax is equal to b. Then we divide both sides by minus 2a minus 2a. That's just one more. Then we know that this cancels that. Then we have x is equal to minus b over 2a. That's where the minus b over 2a formula comes from, by using differentiation. I'm hoping we are all together there. Okay, I don't see any questions in the chat. I'm going to share my other screen so I can show you how our A, B, C, and D values affect functions. Let me just close this quickly. Speech is coming up, just a second. Here we go. Okay, I'm hoping you guys can see that screen. So we have a function y is equal to x to the power 3 plus bx squared plus cx plus b. Okay, now I'm just going to move the sliders to show you what those sliders do to our function. So let's start with a. So now we have a at 1. Let's maybe change it to the negatives. So you see, as you change it to the negative, it will start. So okay, let's look at it. Let's put it there at 1. So here it is at 1. I'm going to move it to slightly to the negative side. Slowly, slowly. Okay. So we still have a graph that starts by increasing from the left-hand side. That's 0, a being 0, 1. And then if it's 0, we get a parabola, which is perfect because why do we get a parabola? Because it means that ax to the power of 3 is gone. Now we just live with a function that is bx squared plus ax plus d, which should be a parabola. So this is what happens when you play around with a. Okay, now let's check what b does. Okay, so you can see the excuse me, so you can see the movement there, but it doesn't affect our point of inflection. Let's check what C does. Narrows our graph or makes it even bigger. Let's check the D value. So that will shift your graph up and down. And that's what the A, B, C, and D values do to our function. Okay. We're moving on to doing some work now. And let's undo that. Screen share coming up. I am sharing my screen there. Let's look at some problems. Okay, so here they say, given the cubic graph, p of x is equal to 2x to the power of 3 plus x squared minus 8x minus 4, where a and c, x-intercepts, f is the y-intercept, and e is the stationary point. Okay, and they clarified that. The first question says, determine the coordinates of e. Correct. That shouldn't be a problem. What do we know about e? That is a turning point, right? And how do we find turning points? We differentiate. So I can immediately say p prime of x equals to 0. And I'll say 0 equals to 6x squared plus 2x. Yes.
But the question here, it says When we are asked to draw a graph, how do we see that we need to draw a bending graph in calculus?
Sorry, please repeat the question. Yeah.
So how do we see that we need to draw a bending graph in calculus when we're asked to draw a graph?
Okay, all right. That's a good question. So the easiest way to know what your graph is going to look like is you have to find all the necessary information, right? So find your intercept. So this is very important. Your x-intercept. After finding your x-intercept, go for your turning points. Okay? After finding your turning points, then go for the point of inflection and the y-intercept. Once you have all those things, all you're doing is you are going to join them and also look at your A value. Like I said, if your A value is positive, then your graph is going to take that form. If your A value is negative, it's going to be in that form. But you need your intercepts, turning points, y-intercept, point of inflection, and then you just join them to get the shape. Otherwise, we can't tell what the shape is going to look like without having those things. Okay. Then, lastly, here we're going to have that 8. I was deriving this. Now we just need to solve for x. So I have 0 is equal to 3x squared plus x minus 4. I'm going to try and factorize that. So I should have 3x plus 4 and x minus 1. Yes, that should work. Then x is equal to negative 4 over 3, or x equals to positive 1. Then we know that the coordinates of E, so E is going to take the positive 1. All I need to do is substitute the 1 into the original. So I'm going to find P of positive 1. Okay, so it's going to be 2, 3. That's going to be minus 9. Okay. Then we're done with the coordinates of E. Now, show that x minus 2 is a factor of P. How do we show that it's a factor? All we need to do is we need to take the 2 and substitute it back. So we need to find P of positive 2. Okay, so x minus 2 is a factor. So let's find P of minus 2. That should give I'm going to go back to this was 2x to the power of 3 6. And the last one was just a minus 4. So all we need to do is substitute P to be 2. And if we do it, then we should be getting, let me just write it out. It's this, cancel that, cancel that. So x minus 2 is a factor. Put it all together there. Now, determine the distance of AC showing all methods working. Distance AC. Okay, that shouldn't be a problem. We are looking for that distance there. Remember that we have a factor. So let's change my color. Okay. So x minus 2 is a factor. Okay. Now, what do we have here? How do we even find that? What I use is the K method, right? I know people might be using synthetic division, long division. You're more than welcome to use whatever method that you are comfortable with. So I'm going to go to the K method, which I think is the easiest one. So pay extra attention if you don't know the K method. So here I'm going to have x to the power, I'm sorry, 2x to the power of 2, because all we do is we take the first, we divide it by the first in this bracket. So 2x to the power of 3 divided by x, that gives you 2x squared. Then in the middle, this is the K method. We always just say plus kx. Then we take the last term, we divide it by the last term in our bracket. So minus 4 divided by minus 2, that gives you positive 2. Minus 4 divided by minus 2, remember, with the signs. Please always be mindful of the signs. Now, I'm going to multiply out everything in the bracket so that I can show you what I am actually doing. Just bear with me for a second. So if x multiplies by everything in the bracket, I'm going to have 2x to the power of 3 plus kx squared, then plus 2x. Now if the minus 2 multiplies, I'm going to have minus 2x squared. Sorry, minus 4x squared minus 2kx minus 4 if I multiply that. But what I want to look at is the x squared terms. So this part and that part, the x squared terms. I'm going to say kx squared minus 4x squared. This must be equal to what? To the original x squared, which was this 2. Then I can solve for k. Kx squared equals to 5x squared, which means that k is equal to 5 if we divide both by x squared. Now we're winning because we have x minus 2 into 2x squared plus 5x plus 2. Now, when we're here, we can rely on our calculators to find or to factorize that if you're not too good with factorizing. I think I can factorize this to 2x there, and x there. 2 will only be 1 and 2, and then they will have to be both positive. Okay, now we have our points. So this is 2, this is negative 1 over 2, and minus 2. So which one is the minimum one? Minus 2. And the maximum one will simply be 2. So what is the distance? The distance is simply going to be 4 units. Okay, I'm not seeing any questions in the chat. Going to carry on. 9.4. Determine the equation of the tangent at F. So a tangent at point F. Right. So that tangent is touching the. How do we find that? Okay, before I do that, there's a question in the chat. Where did I get the 4 units? All right. Good question. So the 4 units is, remember, A is minus 2. It means that the distance from the origin to point A is 2 units. Then the distance from the origin to C is also 2 units. Now, what is the distance between A and C? It will be 2 units and 2 units, which will give us 4 units. Remember, distance, you don't have negative. That -2 is just showing you that it's going on the left-hand side. For distance, they will usually say you take the absolute value. If you're not seeing it, please use the distance formula, because the coordinates of A are -2 and 0. The coordinates of C are 2 and 0. Use the distance formula to find that. I hope you answered them, Marcelo. All right. So I was doing the question that wanted us to find the equation of the tangent passing through F, point F. Let's find the coordinates of F. I'm going to clear some of my working out here so that it's a little bit cleaner. The coordinates of F, we know we have 0 and -4. All right. Now that we have that, we are going to try and find the gradient at point F. Remember, whenever you're finding the gradient of a straight line, you either need 2 points. Because if you have 2 points, then you can find the gradient, and then you can substitute 1 point to find the equation of a straight line. Or if you have a gradient and 1 point. So here we don't know what that is, and it will be impossible to find point F because we don't know where this line is going to pass through again. We know that it's passing through F. So we're going to try to find the gradient at F. Now, what was our gradient? Remember when we derived the P prime of X, it gave us 6x squared plus 2x minus 8. Okay. Now, we wanted at point F when x is 0, which means that the gradient is going to be -8 because we found P prime of 0. I'm hoping we're all together there. Now that we have that, we're going to use y minus y1 equals to m into x minus x1. So y minus -4, can immediately just say +4, equals to -8 into x minus 0. Then y equals to -8 x minus 4. And that is the equation of the tangent passing through F. Okay, no questions in the chat. I think we're all good. Okay. And
That's a ban.
yes.
They're saying, can you please repeat that question?
Okay, I'm going to just quickly go over it. So the question itself is saying, determine the equation of the tangent at F. So there's a tangent. A tangent, what is a tangent? It's a straight line, right, that passes at that point only once. So we know there's a straight line passing through F. Okay, now we don't know the direction of this straight line. Maybe it's something like that. My handwriting is not the greatest. Could be something like that. I'm trying to just draw a straight line. Yeah, passing through F. What we need to find the equation of a straight line is a gradient and a coordinate. Because here we won't be able to find another coordinate. We will have to find the gradient and the coordinate. The coordinate is easy for us to find because those are the coordinates of F, and that is the y-intercept. For the y-intercept, we make x 0 so that we find the coordinates of F to be 0 and -4. Because the equation wants that. So if you make everything 0, this equation, that falls away, you're going to be left with minus 4. Hence the coordinates of f are 0 and minus 4. Now the gradient is what we need. What do we know about the gradient? The gradient is the derivative. But if we're looking for the gradient at that point, we have to substitute what that point is. That is why I said if p prime of x equals this, because it's the derivative, it's the gradient. But then I'm saying the gradient is the gradient at that point. I have to substitute x to be 0. So p prime of 0 equals to the gradient at that point. Then I found my gradient to be minus a. Then I used y minus y1 is equal to m to x minus x1, the equation of a straight line. If you are more comfortable with y is equal to mx plus c, find the c value first, that's perfect. We are going to get the same answer at the end of the day. You can use that one. Then from here, all I did is I substituted the points that I had, and the set of coordinates of f and the gradient, which is minus. And then there is my equation for the straight line. Okay. Okay. Then I'm going to jump. I want to come back to this one a little bit later. We will definitely do it. Even the maxima and minima. All right. I want to look at 9.2.2, that question there. They want us to find dy over dx if y is equal to x minus 2 over x all squared. All right. I want to show you how you tackle this kind of a question. So when you have this kind of a question, please do not bring the 2 in. What you need to do is you need to remember that the 2 tells you about 2 brackets. And let's have those 2 brackets. We are going to have x minus 2 over x and x minus 2 over x. That's what the squared is going to stand for. Key thing, kx in. Now we can FOIL it out. First, x squared. Then outer, we're going to have minus 2. Inner, minus 2. Remember, outer x multiplied by that. These x's are going to cancel each other out. And then last, we're going to have plus 4 over x squared. Then let's clean this up. Let's also be x squared. I want to say plus 4x to the minus 2 minus 4. Then differentiate. Because it's in the form kx in, kx in. This will be 2x minus 8x minus 3. And that's it, because the constant will fall away. And I showed you why it falls away. Okay, hopefully we're all together there. I'm just going to skip a few of them. Okay. Just a second. Okay. Just look at this one here. Right. So they put 2 asterisks there to show that it might be a bit of a challenging question. They want you to find the derivative of the following using first principles. We know that this is the same as x to the power of a half. If you differentiate, you're going to have half of x to the negative a half. Okay, but they want us to use first principle. How do we even go about that? We know the derivative f prime of x is equal to the limit as h tends to 0 of f of x plus h. So it's going to be root of x plus h f of x plus h minus f of x all over h. There's nothing I did there. I just substituted f of x plus h and f of x. Now remember, you never ever drop the limit. The limit as h tends to 0. Okay. What are we going to do here? What's the next step? What we need to do is we need to multiply by 1. Okay. But the 1 is up to us. We need to be smart about the one that we're going to multiply with. The one that you're going to multiply with is in verse 4. X plus h under the square root plus root of x plus h under the square root plus root of x. That's what we're going to multiply with. This is 1, so it doesn't really change anything. Now, if we multiply the top there, what I'm going to have, so first, I'm just going to put this in brackets, doesn't really change much, so that I can multiply properly. First, this multiply by itself, what's going to happen there? So you can clearly see that the square root is going to fall away. We're going to have x plus h. That's first. And then outer, we're going to have what? We're going to have root of x multiplied by root of x plus h. Then inner, we're going to have minus root of x multiplied by root of x plus h. Then lastly, we're going to have x, because root x multiplied by root x, we're simply going to have root x. Now down here, we simply have x into, I'm not going to multiply it out, I'm just going to leave it as x plus h plus root of x, just like that. Take the limit as h approaches 0, we keep it there. Now let's see what cancels out. And here you can see that there's stuff that's canceling out. This with that. Okay? X with x there. What are we left with on top? Simply left with an h. Okay? Down here we still have h into x plus h under square root plus root of x. Now you'll see that this h cancels that h. We make some more space. What are we left with on top? We're simply left with 1. Okay? Now we can make this h approach 0. If that h approaches 0, what do we have? We have root of x plus root of x. What does that give you? 1 over 2 root of x. Right? Which is exactly what we have there, because we can take this square root up. So 1 over 2 stays there, and the square root is the same as x to the power of a half. If it goes up, it is 1 over 2. Here it's x to the power of negative a half, which is exactly the same answer that we have here. That is how you do that kind of a question. Now, I'm pretty sure by now you've seen that calculus is very much repetitive, right? You know how to differentiate using first principles, using rules, and the different notations. You will get quite a lot of marks. Okay. Now, what I want to jump to is to do another question where we find the where we sketch a graph. Maybe let's sketch a graph together. Okay, I'm going to share another screen in a second. Just a second. Before we jump to application of calculus. So suppose we have a function which is f of x is equal to just a second, let's see if this one is going to work. Let's consider this function 2x to the power of 3 minus 17x squared plus 41x minus 13, like that. And what we need to do is we need to sketch it. And somebody will ask, how do we know the shape? So pay extra attention, please. Let's first find a factor. Right? How do we find a factor? I'm sure you guys know how. I'm sure you all know how to find the calculator. Okay. If we use our calculator, remember you're going to go to the table method. So you just go to mode, then you press 3 for table, and then you type in f of x as it is. If you do that, you will see that x minus 2 is a factor. Now, because x minus 2 is a factor, what we're going to do is we're going to say x minus 2. Now, here I'm going to write my block bracket. Even if you wrote soft brackets, that's so fine. Pay extra attention. First divided by first. So 2x to the power of 3 divided by x is just 2x squared. Then in the middle, what do? We always say plus kx. It's the k method. Now, we always say last divided by last. So negative 30 divided by negative 2. That gives you positive 15. Okay? Now, all we want is the x squared components. So I know I'm going to multiply to get x squared. I'm going to multiply this with that. And I'm also going to multiply these two, only those. So I'm going to have minus 4x squared plus kx squared must be equal to the kx, to the x squared in the original, which is this. That's what it must be equal to. And I'm going to say equals to minus 17x squared. Then all we need to do is solve for k. So kx squared is equal to 13x squared. Negative 13 because the 4 came that side. Now k is equal to minus 13. Then we know we're winning because the k value that we just found belongs there. Which means that actually up there, what we are trying to solve is 2x squared minus 13x plus 15, which is easy to factorize. Quadratic formula. Then if we factorize that, we should have 2x here and x there, negative and positive. That should be negative, negative. Then 15 should be 3, 5. We do have the 3, yeah, the 5 there. Check it works out. Minus 10, that works out. Then it means that I have my 3x intercepts. So I have 2, I have 3 over 2, and I have 5. If I look at the order, this one will come first. Just like that. Now we have our x-intercepts. What do we then need to do? We need to go to the turning points, right? But remember we have, so we know that all of those y will be 0 because those are implicit. We don't have to find the corresponding y value. If you want the y value, we just make everything 0. So the y-intercept, y-int coordinates will have 0 and minus 30. Turning points. We got it around turning points. So f prime of x equals to 0 for our turning points. So 0 is equal to 6x squared minus 34x plus 41. Just differentiated that. Right? Then what we need to do is check if we can factorize that. I don't think I'll be able to factorize that. Can't divide by 2. I'm going to rely on the quadratic formula. We have a silver calculator. You can do that quickly. Silver calculator to find those intercepts quickly. So number 2. So my A value is 6. My B is minus 34. And then my C is 41. Okay, so my first x value is 17 plus root of 43 all over 6, or x equals to that, but with a negative. Let me just say plus or minus. This is, so the positive one is going to be 3,92. The negative one will be 1,74. Okay. Those are our turning points. This will be the one on the far left. And because we are dealing with a positive A, we know the shape of our graph is going to be like that. It starts by increasing, right? If that's the case, I'm going to draw something that looks a little bit like our graph. It's something like that. We have our turning point. So the first turning point was at 1,74. Next turning point was at 3,92. Okay, now these are all x values. How do we find the y? We have to substitute the corresponding turning point in order to find the y value, even here. Then we're not done. We also need to find the point of inflection. And that's the easiest one because you differentiate again. And let's do that. 0 equals to 12x minus 34. 34 equals to 12x divided by 12. 17 over 6 is equal to 8. And that is the value of y, the value of x on the point of inflection. I'm hoping that makes sense. If you didn't know how to sketch, from here it should be quite easy and clear for you guys to do. Okay, I'm not seeing any questions in the chat. I think we are all fine. Okay, I'm gonna go up now so that we can look at some application of calculus. And we'll come back to that one. I want to start here. All right. So here the thing, in the diagram below, PQR is a semicircle, right? And P plus Q equals to 20. So that length, P plus Q, those chords, if you add those two chords, will give you 20. Calculate the lengths of P and Q that will give the triangle or triangle PQR a maximum area. Show all calculations used to determine your answer. Okay. Let's see. Firstly, what I know is that angle R is 90 degrees. Okay, so R equals to 90. Y angles in a semicircle. Okay, now because I'm working with a triangle and looking for the area, I know that the formula for that is going to be, so area equals to half of the base multiplied by the height. So it's going to be half of what? Of P, and the height is going to be Q. I'm hoping we're all together there. Now remember something. We do have what P plus Q is. So what I'm going to try and do is maybe solve for P. P is equal to 20 minus Q. Then I'm going to try and substitute this in this equation here. So the area is equal to half 20 minus Q multiplied by Q. Now this is half of, and we put that Q, I'm going to put it in front so I don't have to, no, I'm going to put it here. There we go. So this should be 10Q, I've multiplied by 20 is 10, then the Q stays there, minus half of Q squared. Now, for max area, for maximum area, A prime, right, must be equal to 0. Now 0 is equal to 10 minus Q. Then Q equals to 10. Then we know that P equals to 20 minus 10, which is equal to 10 units as well. I'm hoping we're all together there. I'm not seeing any questions in the chat. Everyone is still fine. Unless there are some questions from you on TikTok here.
There's nothing, Sebastian.
Okay, perfect. This was still good. Right. I'm going to move on to more application of calculus. It's a question that's so here. After the question. Okay, so here's a question. The rectangular milk carton has a square base which holds 1,000 centimeters cubic or a liter of milk. It has a specially designed hole in top. The area of the cardboard used for the top is 3 times the area of the base. The height of the carton is h, and the side of the base is x. Okay, so they are the dimensions of that rectangular milk carton. Show that the total surface area of the carton in centimeters cubic is given by that day. So ax equals to 4x squared plus 4,000 over x. let's see what we can do. Okay, I'm gonna zoom in now. So yeah. What I'm going to do is I'm going to try and find the area of the square base. So this is very important. The square base. Let's try to find that area. So this area will simply be, let me just do this. So the area of that is x squared because it's length times breadth. Now, I know that the volume V is equal to length times breadth times height. But what is the volume? I'm pretty sure the volume is given big, 1000 centimeter cubic. So I'm going to say 1000 equals to the length, which is x, the breadth, which is also x, and then the height is just that. Right? Length times breadth is the area that we calculated there. So I could have just substituted x squared. I'm just doing this so that you guys are with me. X squared multiplied by h. Now we can find h in terms of x. H equals to 1000 over x squared. All right. Now, what we are looking for is the total surface area of the carton. TSA. How do we find that? It's going to be the area of the top and bottom. So for top and bottom, top and bottom, just need to multiply this by 2. Okay. Then there's the front and back. Front and back. What is the area of the front and the back? It's just h multiplied by x. But I need to multiply this by 2. Please make sure that you are following, that you are with me. So the front, the area of the front is the height multiplied by x. But this side that we are looking at in front also exists at the back. That's why I'm multiplying by 2. Now looking at the sides, the side on the right and the side on the left, the area of that would be hx as well, but multiplied by 2 because of the two sides. Now it means that the total surface area must be 4 that will be 4hx plus 2x squared. Okay? I just added everything up. So 2 of this to there and that. So 2hx plus 2hx, that gives you 4hx. Then x squared multiplied by 2 is just 2x squared. Then I'm going to put in what I have, plug in what I have, which is h. A equals to 4 multiplied by 1000 over x squared multiplied by x plus 2x squared. Then let's check. Here we are going to have 4000, the 4 multiplies, over x plus 2x squared. Okay, I'm gonna go up and just double check if I haven't made any mistake. So 4,000 over x, I'm happy with that. And we're not talking about the maximum. So I'm not supposed to differentiate yet. The length times breadth. But I'm hoping it's not a mistake. Just give me a second to double check that I didn't make a mistake on my side. The area of the cardboard used for the top is 3 times. Okay, that shouldn't be a problem at the moment. Okay, there might be a comment in the chat. Okay, the network will always be a challenge. Okay, I'm just trying to check where they got the 4. If you can see it, you're more than welcome to let me know in the chat because I'm getting 4,000 over x, which is fine. They have 4 and I'm getting a 2. So I'm just trying to go back to see if I might have made a mistake somewhere. So the bottom, x multiplied by x, which just gives me x squared. Now, the top as well.
Yes, Papa.
Is there?
Let's check the chat.
Okay. So maybe the x squared should have been x4 for the top. And for the top of 3 and plus 1 at the bottom. Pharmacy, can we unmute you so that you can maybe explain better what you are trying to say? I'm not too sure I'm following what you're saying there. Here, can you please help unmute them?
Yeah, you can unmute now.
Pharmacy, can you please unmute yourself and maybe just explain what you meant by your comment in the chat? Maybe they're not looking at their screen at the moment. But they should be able to unmute whenever they are ready. Okay. I don't think I made a mistake. It could also, so this is a prelim paper. It could be a mistake in the question itself. Sometimes they do make mistakes, but I'm not saying it's a mistake. I just can't see where I could have went wrong because I tried to do it. So the top and the bottom, so I just do 2 up so that I can have 2x squared. I'm not seeing what else, what it is that I should change, unless I'm misunderstanding the question. Yeah. It was supposed to be. I see. I understand what Mr. is saying. So there's no problem with the question. It was just me misunderstanding. So if you look at this, so they actually guided us because they shaded. So we need to find the area here. That one over there and this one here, because that'll give us the total surface area. Now, how many do we have? So it's not just the top and the bottom. So it's the one at the bottom plus, so let me just say 1, 2, 3, and 4. You are actually correct, Mpangwas. Thank you so much for that. So it will be those 4. So instead of multiplying by 2, I need to multiply by 4. Then it works out perfectly. Because this just needs to change to a 4 and a 4 there. Then we have exactly what they're looking for. Okay. Before we move on, if you have a question, please do ask. Don't be left behind. Okay. Next question. Questions in the chat. Determine the dimensions of the carton so that the minimum amount of cardboard is used. Okay, so if we are looking for a minimum amount of cardboard, if we want to use a minimum one, we have to differentiate the area, and it must be 0. So we'll say a prime in terms of x is equal to 0. Now, let's differentiate that. It's in the form 4,000 x to the minus 1. That one is perfect. So 0 is equal to minus 4,000 x squared minus 2 8, plus 8x. Then 4,000 over x squared must be equal to 8x. Then what we can do is we can cross multiply. 8x to the power of 3 is equal to 4,000. Divide both sides by 8. X to the power of 3 will give you 500. Find the third root. X is equal to 7,94. And if x is 7,94, what did they say about h? H is 1,000 over x squared. So h is equal to 1,000 over 7,94. And our h is going to give us 15,8. I'm hoping you guys are with me there. Okay, I'm seeing questions in the chat. I'm going to carry on. There is another question. We need to use applications. Let's look at that. A rectangular box is constructed in such a way that the length of the base is 3 times. If we just highlight that, it might be very useful. Okay. Then the material used to construct the top and the bottom cost 100 rand per square meter. The material used to construct the sides of the box cost 50 rand per square meter. The box must have a volume of 9 meters cubic. Let the width of the box be 8 meters. Determine an expression determine an expression for the height 8 of the box in terms of 8. Now, I know that the length is going to be equal to 3x. Then the volume is equal to length times breadth times height. And remember that they don't give you the formulas for these shapes. You have to remember them. Now, let's substitute what we have. The length, that's going to be 3x. The breadth is just x, and the height is just h. Do we have anything else? The box must have a volume of 9 cubic meters. So this is equal to 9. Let's solve for h. 9. These two multiplied together, that'll be 3x squared. Divide both sides by 3x squared. Simplify, h is equal to 3 over 8 squared. Okay? You get 3 marks for that. Next question. Show that the cost to construct the box can be expressed as c is equal to 1,200 over x plus 600 x squared. Okay? That shouldn't be too bad. Now, remember when we construct, we have to rely on what? On the area. So, the area is going to be 2 times LH plus 2 times XH plus 2 times LX. And that's the area. But now we need to substitute what we have. So if we substitute, we are going to have our cost as 2 times 3xh, okay, plus 2xh. But these are multiplied by the cost to make it, which is 50, then plus 2 times 3x squared, but then multiply by 100, because this cost 100 rand. And they did say that it does cost 100 rand for the bottom is per square meter. Now, let's try to simplify that. If we're getting 8x, and I know h, if this is 3 over 8 squared, then plus this is multiplied by 15, and then plus 600 x squared. Then it's just a matter of simplifying now. So we simplify, multiply the top, it's multiplied by 8, multiplied by 3. You should be getting 1,200 over x, because 1x cancels your thing there, and then 600x squared, so 600x squared. And this is the cost to construct that routine. No questions number. Right, repeat, sir. Okay, not a problem. So show that the consequence of the box can be expressed as t is equal to 1200 over x plus 600 x squared. What is the cost to construct? Remember, what we're constructing is the area. So we need a box. So we don't need the volume because inside the box, we need it to be empty so that we can put something inside the later stage. All right? Now, because we're going to be looking at the cost, to make it easy for you, you need to use that formula. If you use this formula, maybe you want to do it this way: 2 into LH plus XH plus LH. Substitute what you have. If the 2 is outside, I just took it out as a common factor. Right? What was our length? 3x. What was our height? I think we got it to be 3 over x squared. Then x is just x because our height, 3 over x squared. Then plus, what is our length? 3x multiplied by x. You want to do it in that fashion. Then all you do is you multiply out and substitute your value for x. But if you do it in that form, you need to be very careful which one costs more. Remember, they did say something that the material used to construct the top and bottom. Which ones are the top and bottom? So length, so the top and bottom, I will 8. So this part and that part. Right, let me just fix that. The top is length multiplied by 8. So that part. That costs 100 rands per square meter. That's where you mark up the 100 rands. But everywhere else, you mark up to the 50 rands. So this part is multiplied by 100. That's for this. And then here, that's where you're multiplying by 50 rands because it costs 50. Then you just simplify that. You will get to the same answer. Okay. Now the last question. Calculate the width of the box. That is the value of x if the cost is to be a minimum. Okay. Now, let's quickly look at that. So we know that the cost is 1,200 x to the minus 1, 600 x squared. If the cost is to be a minimum, we know that c prime of x must be equal to 0 for minimum. 0 is equal to negative 1,200 x minus 2 plus 600 x squared. Then 1,200 x minus 2 is equal to 600 x squared. Then I didn't differentiate properly. Derivative of that must be 1,200 x. No mistake. 1,200 x. This is 1,200 over x squared is equal to 1,200 x. Then let's fix that. We cross multiply. We should be getting x to the power of 3 is equal to 1. Because you're going to have x to the power of 3 is equal to 1,000. So 1,200 x to the power of 3 is equal to 1,200. Divide away the 1,200. So x is equal to 1. So the width of the box must be 1 meter. Okay. Hoping that makes sense. And by the way, the reason we always look for maximum and minimum is, remember, this relates to your graph. This is the maximum turning point and that's the minimum turning point. That is why the derivative, that's why we always take the derivative of the cost or the volume to be 0. Whether it's minimum or maximum, it doesn't matter. We just differentiate and take it to be equal to 0, because this relates to a function. Okay, it is now 8 o'clock. If you have questions for me, please maybe just post them in the chat or raise your hand so I can quickly answer your question before we call it a day. Theo, are there any questions on TikTok?
No, there's nothing to that.
Okay, the Zoom chat also looks clean.
No, there's nothing also that.
Okay, all right, perfect. Thank you so much for joining today's session, guys. That is me for today, but we still have 2 more minutes. Well, we are over time. It is 1 minute after 8. If you have to leave, you are more than welcome to log off. But if you have a question, I will be here for 2 more minutes so that I can answer the question that you might have for me.
So, Tepan,
Yes,
there's a
dear.
question on TikTok. It's saying,
Mhm.
do you go live every day?
Okay, no, we don't go live every day, but we go live Monday, Tuesday, Wednesday, and Thursday. For unforeseen reasons, we weren't able to have this lesson that we're having now on Monday. That's the only reason we're having it on Friday. But we go live Monday to Thursday from 6 p.m. until 8 p.m. Mondays and Wednesdays, we do math. Tuesdays and Thursdays, we do physical science. I think I've answered them here.
Yes.
All right. And I'm going to, please prep the video. I'm going to stop sharing my screen in a second. And then you can take us away with our outro, because I see we don't have any questions. Somebody's asking for next week's topics. Okay, they are coming up. Just a second. It's just loading. So Monday we are doing statistics. Tuesday it's electrodynamics and optical phenomena. Then Wednesday it's going to be probability, continued probability. Thursday electrochemistry. Then we have covered everything. Then the week after we will be doing a revision for paper 1, math and science. And then that other week we will be doing a revision for paper 2. But next week, stats. Tuesday, electrodynamics and optical phenomena, probability, and electrochemistry. All right, Theo, I think you can take us away.
Guys, we'll see you on Monday. Have a great weekend. Bye.